So now we're going to talk about dividing fractions. So let's start with 5/6 divided by 1/3. All right, so to do division, we actually use multiplication. So we're going to do what is called invert and multiply. So what you do is you keep the first number as it is. You change from division to multiplication, and we flip the second number. We invert it. All right. So this becomes 3/1. And then I'm doing 5 times 3 is 15, and 6 times 1 is 6. Both of those can be divided by 3. So 15 divided by 3 is 5, and 6 divided by 3 is 2. So our final answer would be 5/2, or 5/2. Or we could have also back here, we could have said, okay, once we got it written down by inverting and multiplying, we could have said, oh, 6 and 3. Hey, 6 and 3 can both be divided by 3. This becomes a 1. This becomes a 2. 5 times 1 is 5. 2 times 1 is 2. And then you still would have ended up with the same answer of 5/2. So when we are going to divide with negatives and positives, it's the same rules as before. If there's only one negative, the answer is negative. If it's two positives, the answer is positive. If it's two negatives, the answer is positive. In this case, we have one negative, and our final answer should be negative since there's only one. I'm going to copy the first number. I'm going to change from division to multiplication, and I'm going to flip the second number. So now I've got 5 times 5 is 25, and 6 times 2 is 12, and it should be negative because there was only one negative. 25 and 12 have nothing that they can both be divided by, so this will be our final answer, -25/12. If I need to solve a problem that involves mixed numbers, I'm going to change those mixed numbers into improper fractions. Again, improper fractions are much better for dealing with than mixed numbers when it comes to multiplying, dividing, adding, and subtracting. So we're going to take 3 times 1, which is 3, plus 2, which is 5. So we're going to have 5/3. And we're going to keep it as division for just right now. And 2 times 2 is 4, plus 1 is 5/2. Then I'm going to keep the first number, change from division into multiplication, and I'm going to flip the second number. And I multiply across the top. 5 times 2 is 10. 3 times 5 is 15. And both of those can be divided by 5, so my final answer would be 2/3. So here I have a whole number that's being divided by a mixed number. In order to turn a whole number into a fraction, we simply put it over 1. So this is going to become 7/1 divided by 4 times 1 is 4, plus 3 is 7/4, which is going to become 7/1 times 4/7. 7 times 4 is 28. 1 times 7 is 7. In this case, since 28 divided by 7 is actually equal to a whole number that's without any fractional piece left over, we can just simply turn it into 4. That is one case in which we would want to go from a improper fraction into just simply the whole number answer. But that doesn't always happen. I would also have accepted that both 7 and 28 can be divided by 7, so it would be 4/1. Either of those would be acceptable answers. They're both the same thing. And for my final example, I'm going to solve yet another problem involving mixed numbers and whole numbers. And I'm also going to, as you can see, it has two negative numbers. So first things first, I'm going to change my mixed number into an improper fraction. 3 times 5 is 15, plus 2 is going to be 17 fifths, divided by, and that was negative, divided by -8, which I'm going to turn into a fraction by putting it over 1. Then I'm going to invert and multiply. So I'm going to keep the first number, change to multiplication, and I'm going to invert or flip the second number. So this is going to become 1 over 8. So 17 times 1 is 17. 5 times 8 is going to be 40. And because they are both negative, the answer is actually positive. 17/40. 17 and 40 cannot be divided by anything, both of them. So this is our final answer. It is simplified. Now I'd like you to take the information you gained from this video and use it to solve some of your own problems in the link in Canvas.